Let's go over 3 multiple choice questions about enzyme inhibitors. There's going to be an easy, medium, and hard question, and I'm going to review the answer to each. With that being said, let's just jump right into it. Here's the easy one. A metabolic pathway slows down when its final product binds to an enzyme at the beginning of the pathway, reducing the enzyme's activity. This is an example of blank. The reason why this is an easier question is it's basically asking, have you memorized the definition? Because this question is basically just a big definition of feedback inhibition. Feedback inhibition is when there are several reactions that occur together, one after another, and the final product is going to inhibit an earlier step. So this question is easier just because it's just a rote memorization question. Here's the medium question. Which of the following best explains why competitive inhibitors reduce enzyme activity? Remember, in a reaction, we have an enzyme, and that enzyme is going to have an active site. So here's our enzyme, here is our active site. What happens is a substrate will bind with that active site unless an inhibitor takes its spot. Sometimes these inhibitors will look something like the substrate, however, they won't allow the substrate to bind in when the inhibitor is there. So A, they prematurely denature the enzyme. No, we didn't talk about denaturing the enzyme at all. B, they bind to an allosteric site and distort the enzyme's shape. That would be good for non-competitive, but this is asking for competitive, so B is out. C, they block the active site so the substrate cannot attach. That sounds like our answer. D, they attach this substrate and prevent it from entering the enzyme. Nope. And substrates don't really enter the enzyme, they react with it, but they're not entering it. E, they increase the activation energy of the reaction. I like this activation energy term because that can confuse students, but that's definitely not the answer here. This is why the correct answer is C. Here's the hard one. How does a non-competitive inhibitor decrease the rate of enzyme reaction? So we just talked about the competitive inhibition. Now we're looking at non-competitive inhibition. A, by binding at the active site of the enzyme. That's competitive, so that's not what we're talking about. B, by changing the shape of the enzyme's active site. I like that answer. It didn't talk about the allosteric site though. Let's see if there's a better answer in C, D, or E. C, by changing the free energy change of the reaction. No, we don't really deal with that with these inhibitors. D, by acting as a coenzyme for the reaction. No, those coenzymes will actually usually help. E, by decreasing the activation energy of the reaction. I mean, all enzymes do that, so no, these are going to be trying to describe the non-competitive inhibition. That's not right. So B is the best option. Even though it doesn't talk about the allosteric site, it's still our best option for here and is the correct answer.